Hello dear students, let us start this course by a very beautiful and very meaningful quote which is written here. If an egg is broken by the outside force, the life ends. But if it is broken by the inside force, the life begins. Great things always begin from inside. What does it mean? It means that any egg, if it breaks from the outside, what happens? The life inside of that egg, it dies, right? It's the end of a life. But if it is breaking from the inside, means whatever living being is within that egg, that is opening up the shell, that is breaking the egg. It is the beginning of a life, right? So great things always begin from the inside. Always look for inner inspirations and not external motivations. Always look for discipline which comes from within, right? This is something that you must realize, and it's a very important learning for you, not only as a GATE aspirant or any exams aspirant, but throughout in your life. Now, why are we discussing this here in strength of materials? Let us focus on the first part of this. If an egg is broken by the outside force, the life ends, right? Any outside force, any outside load which is unwanted, in most of the times on any given body, on any component, has a negative effect, right? It tries to break it, crack it, bend it, distort it, deform it, right? As an engineer, it is your duty to ensure that the external loads and external forces are not having a very dangerous effect on the body, right? In this case of egg, you cannot control it, right? Because humans don't manufacture the eggs, and obviously since you want the egg to get broken from the inside, so obviously it's not good that egg is very hard. Coming to the points, coming to the components that we design, that humans design, and especially we design them to be in use for long and long years. We want them to be of such a quality that they don't get bent, distort, deform due to any external load, any external force that is being applied to them, right? That is what we are going to study in strength of materials. There are a variety of things that can go wrong with any component that we have. Any component under use, under the action of external force, external load, either it can get bent, right? I have shown you a bent spoon, a very small example I am giving you right now. Or there can be cracks in that particular component, particular material, which can propagate, which can increase and finally break that particular component, right or not? As an engineer, it's your responsibility, it is our responsibility to ensure a design using those materials, those designs, those components that do not bend, crack or fracture or break under the action of external loads, external forces, right? And that is what strength of materials is going to do. It's a very important subject and very interesting subject, has a variety of practical applications. Whatever component we have, does not matter whether in mechanical engineering or electrical engineering or electronics or computer science engineering, whatever component you have, it is very much necessary to ensure that it does not break, right? Physically it does not break, bend, distort, right? Otherwise it will be of no use. Whether it's any electronics component, as I told you, or any mechanical component, right? Right from a very small needle, right? Or a very small iron nail, to very large ships and buildings and bridges. Everything that we design, from that small size to those large dimensions, large sizes, everything we want to be in the right shape, right size, without any distortion, bending and any kind of fracture and breakage, right? In strength of materials, we are going to study about that how we can ensure that the loads does not do any negative effect on the body. Obviously, there will be negative effects. You cannot say that a force is applied or a load is applied and nothing will happen to the body. You are not God, we are not God, right? But what we can ensure that it does not have a very dangerous effect that will make the component useless, right? That is what we are going to study in detail. Okay, in detail we will study that. But let me tell you, even before we start the discussion, that it's a very intuitive subject. Intuitive means you will be able to feel what we are studying. You will be able to, understand what is going on, sometimes without even understanding the concepts, without even totally understanding what is going on. You can feel that what is going to happen. For example, if there is a thread, okay, a string, a cord, small, thin cord, thin string, and other cord is thicker, right? One small thread, a very thin thread, and another thread we have which is thicker, okay? And what we are going to do now, that we are going to apply a force on these threads, right? We are going to extend it, try to extend it. If one of them breaks, tell me which one is it going to be? If I am applying the same force on two threads, one is thinner, other is thicker, of the same material, and one of them is going to break, tell me which one will break first? This is going to break first, right? Very clear. It's a thin one. If I start asking you the concepts, why? You might not be able to conceptually answer it correctly at this point of time. But intuitively you can feel that this is the one which will break first. Similarly, I will give you one more example at this point of time. Now suppose I have this scale, this ruler, right? If I try to bend it like this, and if I try to bend it like this, tell me which one of them will bend easier? Even without having a scale, you can answer based upon intuitive feelings. This is a scale. If I try to bend it like this, or if I try to bend it like this, what do you think? Which one of them will be easier to bend? Very easily you can answer this if you intuitively feel what is going on, right? Very easy to bend it like this. But if you try to bend it like this, it's not easy. It's something that even without having a scale in your hand, if you just close your eyes and imagine a scale or any such a flat surface, you will realize that it's easy to bend it like this, but it's not easy to bend it like this, right? This is an experiment, right? Which the conclusion of this experiment, you can very easily, predict without even knowing the concept. If I asked you same thing for a different system, for some electrical system, and I asked you the conclusion of that experiment, you might not be able to answer it without knowing the concept, right? At this point of time, we have not discussed why is it able to easily bend like this, but it's not able to bend like this. Material is same, right? The applied moment, applied load is also same. But how is it happening? What concepts are governing this? We have not discussed yet. But still we are in a state to predict the conclusion of this experiment. It's the intuitiveness of strength of materials, and not only strength of materials, this is true for many subjects across mechanical engineering, strength of materials being one of those. So it makes the subject very interesting. Once we are going to cover different concepts of strength of materials, you will realize that why things are designed and made the way they are. You will start realizing it. Whether it's a small table, small chair, or any door or big bridges, you will be able to understand that why they are made in that particular shape. What factors, concepts work behind them. You will start getting a feel of that. So it's a very interesting subject. If I talk about from the point of view of gate, again it's very much important. It's one of the fundamental subjects of mechanical engineering as well as civil engineering. In terms of marks or weightage, if I tell you, the range keeps on changing depending upon the year, depending upon the set. General range is from 7 marks to 10 marks every year. As I told you, it can change. It depends upon which year and which set you are going to get. But that's not the point here. The point is that the concepts that we are going to study in strength of materials are going to be used in fluid mechanics also, in machine design also, to some extent in manufacturing and production subject as well. So it is a very fundamental subject of mechanical engineering. Without totally understanding the concepts of strength of materials, you won't understand and enjoy fluid mechanics, machine design, and manufacturing and production that much. So this subject undoubtedly is extremely important. I want your undivided attention when I am teaching this subject. For any other subject also it is true, but this one being one of the most important ones, fundamentally, conceptually, I want a proper undivided attention from your end. Now, mechanics is a general name, a general branch of study which is divided across many classifications, right? The very first and basic classification of mechanics is between rigid and deformable bodies. Whether the body that we are analyzing, is it a rigid body or a deformable body? On the basis of that, the first classification is done. And then it branches into engineering mechanics, something that we have covered already, right? Strength of materials or mechanics of materials is also a mechanics, right? Fluid mechanics, and even theory of machines and vibrations to a great extent. So that classification is what we are going to study now. So the first classification, as I told you, is based upon whether the body that we are considering is a rigid body or a deformable body. Let us first understand what exactly is meant by a rigid body or a deformable body. Suppose you have a general body shape I have shown here, right? It's a general solid body that I have shown here. On this body, any point, any 2 points you take, any 2 points, it can be this one, or this one, or this one, or this one, or this one, any 2 points you have to take. So I have taken point A and point B. Now this body is acted upon by different external force or loads, okay? Under the action of that, in any general case, it is very much possible that the shape of this body is going to change, or the size of this body is going to change, right? I'm sure you know the difference between shape and size. It's very important. It's a basic English term, but you must know and realize the difference between shape and size. Shape is something which tells you how the body looks from the external point of view. What I mean to say, that if the body looks cuboidal in shape, if it looks spherical in shape, if it looks triangular in shape, right? These all are the shapes of the body. It defines the orientation or defines exterior look of the body. That is called a shape. Size refers to how large or how big the body is, right? So if I tell you through an example, this is a cube which is smaller in size, but the shape is a cube. If I draw another cube, this is also a cube. Both of them are having the same shape, but their sizes are not same. It is smaller in size, it is larger in size. It's a basic difference. I know strength of materials is not to tell these basic things, but I assume some of you might be having any confusion about them. So I cleared it here because it will be discussed in further discussion of strength of materials. So coming to the point that we are having a body here, as you can see here, and this body is acted upon by different external loads or force. Now it is very much possible that under the action of these forces which are acting on the body, the distance between point A and B will change. It can increase, it can decrease, right? A lot of things can happen. A body, a hypothetical body in which the distance between the points A and B does not change, no matter how many forces you apply, how heavy or how large loads you apply, such a body is called as a rigid body. In a rigid body, the distance between any two randomly picked points will not change, irrespective of the external loads or forces applied on that body. Obviously, this is a hypothetical body. No body in the world is a perfectly rigid body, because we know that larger the force you apply, more forces are going to act towards the same target, the result will be visible, right? It may not be visible to the naked eye, but the distance between the 2 points will start to change, will start to increase or decrease, right? But rigid body is a ideal body, is a not ideal, is a hypothetical body, which means it is not real. No body in the entire world is actually rigid. All the other bodies that are available are deformable bodies. What is meant by deformable body? The name itself tells you. Deform plus able, a body which is able to get deformed, which can change its shape, its size, right? Such a body is called as a deformable body. In more technical or conceptual words, any two random points you pick on the body and under the action of applied loads, the distance between those 2 points will change. Such a body is called as a deformable body. All real bodies are deformable. So after understanding the first classification on the basis of whether the body is rigid or deformable, let us see further classification of it. As you can see that rigid bodies are further divided into two different branches of study. First is statics, other is dynamics. Let me brief you about this, although you already have an idea because you have covered engineering mechanics. In engineering mechanics, we don't consider the deformation of the body. We don't consider that under the action of applied force, the shape or the size of the body will change. Rather, we study about the effect of the force by considering the motion of the body, whether body is at rest or body has started to move. That is the criteria on which we discuss in engineering mechanics, right? In engineering mechanics, we have never considered the deformation, the twisting, bending, distortion of the body, right or not? That branch of study is this one. It is called as rigid body mechanics. The engineering mechanics has another name which is rigid body mechanics, where we don't consider the deformable bodies. Even if the body is deformable, those deformations might be happening, but that is not the point of discussion in engineering mechanics. We are only concerned about the motion part of the force, right? That branch of study is called as engineering mechanics or rigid body mechanics. This is further divided into, as I told you, statics and dynamics. This is something that we have already covered in engineering mechanics. Then dynamics is further divided into kinematics and kinetics, right or not? This is something that we have already covered in engineering mechanics. At this point of time, I would also like to mention one more subject here, which is theory of machines. This is another design subject which we are going to cover. In theory of machines also, the parts are considered to be rigid. The deformation of the parts is not discussed. So theory of machines also comes under rigid body mechanics. You will find in some sources that you will be told that theory of machines is a part of rigid body dynamics. But that is not totally correct, because in theory of machines also, statics conditions also exist. When we will cover theory of machines, you will realize that gear trains and some other cases have static rigid body discussion. That is why theory of machines also comes under rigid body mechanics, where both statics and dynamics are discussed. So as you can see very clearly here, that mechanics has been divided into different branches which we deal as different subjects. So you can see how interconnected they are. Mechanics and theory of machines will be rigid body mechanics. And coming to the deformable part now, you can very clearly see two different classifications. One is solids, other is fluids. When we have a solid body which is deforming, you can further classify that into two different branches. One is statics, when the body is not in bulk motion, when the body is at its own place. And the other is dynamics, when the body may dislocate, may start moving. This particular study comes under strength of materials. There are different names given to it: strength of materials, mechanics of materials, mechanics of solids. I'm sure you have heard of these names already. Strength of materials, the course name that we are having right now. Mechanics of materials, MOM. Mechanics of solid, MOS. Right? These are different names for the same subject. As you can see, it's a type of mechanics only, but a deformable mechanics, in which we will be studying about solids under statics. So this is the exact position of strength of materials in this whole tree. At the same time, the dynamics part of solids, deformable solids, we study in vibrations. Vibrations is in our course is a part of theory of machines only. As such, it is mentioned in GATE syllabus separately. Again, a very important discussion, but in our course, it is taught within the theory of machines itself. Okay. Coming to fluids. Fluids again are divided as the same, statics and dynamics. As you can see, this is also divided in statics, dynamics. This will be also divided in statics, dynamics. Fluids again are divided into statics and dynamics. Dynamics again will be divided, as I told you here, kinematics and kinetics. So that complete discussion of fluid is again a subject which we call as fluid mechanics. So as you can see that from a single branch of mechanics, how many different subjects are coming out, right? If I exactly point it out from the GATE syllabus, then mechanics is a subject, theory of machines is a subject, strength of materials is a subject that we are going to discuss, and we have started it. Fluid mechanics is a subject, and the vibrations that we are going to study, that also in the GATE syllabus is a separate subject, although I will teach that within theory of machines. So total 5 subjects are emerging out of mechanics, right? There are many core similarities between all of them because they are originating from the mechanics, but as you can see here, there are differences between them based upon what type of body it is and whether the body is in statics or it is in dynamics. So this is the complete overview. We are going to focus on this part here, which is a deformable body mechanics.